Welcome back. Today I will discuss about classification matrix. So when we develop a model, we need to verify how well that model is working and how we can verify it using this matrix. So first we need to understand what is confusion matrix. So a confusion matrix is a table that shows how well a classification model performs. So I presented an example on this slide. As you can see, there are two classes. One is cancer, another one is non-cancer. And the objective of this model is to predict the cancer or non-cancer. That means it needs to classify which sample is cancer, which sample contain cancer, and which one does not have cancer. So here in this confusion matrix, as you can see, in the column we place the predicted condition that the model predicted, how many cancer and non-cancer, and in row you can see it is the actual condition, the ground truth sometimes we call it. It is presented in towards the row. So first row contains the cancer, then the second row contains the non-cancer. So it compares what the actually model predicted with the actual value, the ground truth. If I move forward, you can see there are 4 parts of confusion matrix. Let's break it down. So first we can start with true positive. So it is presented here. It is also called TP in short. So which is like the model predicted. So model say yes, and the actual or the ground truth also say yes. That's we call it true positive. Then we can move to true negative, which are models say okay, there is no cancer, no, and the actual or ground truth also say no. So that is true negative. Moving forward, there should be 2 type of false thing, like a false negative and false positive. So what is false negative is that we predicted no, but the model actually say yes. And similarly, the false positive is that we predicted yes, but the model says no. So these two are actually the error in terms of prediction or classification by the model. And as you can see, the total population is also calculated using total number of positive and negative samples. Let's understand these terms with an example with cancer and non-cancer. So in this slide I presented the same confusion matrix where I started. So here you can see that number of true positive is 6. So the TP is 6 and number of true negative is 3 here, as well as the number of false positive is 2 and the number of false negative is 1. So using this confusion matrix we can calculate the classification matrix, which I will cover. So let's start with accuracy. So as you can see on the right side we have the same example, and the equation to calculate the accuracy is number of true positive plus number of true negative. So all the truths are at the top, and at the bottom we have the total number of sample, or sometimes we call it total population. So this is the proportion of all correct prediction divided by the total number of sample. So in this example, as you can see, this is 6 plus 3 and total number of sample is 8 plus 4, it is 12. So it is 9 divided by 12, which actually resulted in 75% accuracy. But there are some other cases when the accuracy is not enough to justify a model's performance. For example, here I present a example where a machine learning model try to separate the spam mail from the non-spam email. So it try to separate it. So here you can see in the actual number, you can see the number of spam mail are very less, which is only 9%, but the number of non-spam mail are very high, around 91%. So if that model is always predicted that all the emails are non-spam, then it is already 91% accurate. So as you can see, this is a problem. The model does not learn anything to separate the spam over non-spam. So here, if it always detect non-spam, it is 91% accurate, but it always fail to detect any spam emails. In this type of condition, when the classes are not balanced, here you can see the number of spam emails and the number of non-spam emails are not equal. So in those cases, we need some other metrics to verify our model's performance. We can start with precision. So what it does, it predicts, so when the model predicts yes, how often it is accurate. This is called precision. And what is the equation is that number of true positive divided by number of true positive plus false positive. So here number of true positive is 600 and number of true positive plus false positive is 100, as you can see. So here our equation turns into 600 divided by 600 plus 100, which is 600 divided by 700. So it is 6 by 7, which is the precision. So if all the emails predicted as spam, what percentage were actually spam? So high precision means few false positive. This is very important. So we need to remember this high precision means there are few false positive. Then we have one more matrix which is called sensitivity. It also called recall value, which is actually the true positive divided by true positive by false negative. So here it is 600 is the value of true positive. So 600 divided by 600 plus 300 is the false negative. So here what it does, it is the proportion of actual yes did the model catch. So how many actually yes value or positive value the model captured or model detected. And here we need to remember that high recall means few false negatives. So again, let's understand it. High recall or sensitivity means few false negative. This number is negative. And moving forward, we need to understand the trade-off between precision and recall. So let's start with these two conditions we can have, where first condition we have high precision and lower recall value. Okay, so if you remember that if it is high precision, then the model is careful about calling something spam. The model can miss some spam, but when it says it is spam, it is usually right. And lower recalls also means that I am very careful, the model is very careful about detecting cancer, it might miss some cancer, but when it say it cancer, it is usually right. So this is the first condition or first case. And the second case is where we have high recall value but lower precision. So what it happens that it catch all the spam, okay, but sometime mark a non-spam email as a spam by mistake. And in case of our cancer and non-cancer classification, it catches all the cancer but sometime mark non-cancer as cancer by mistake. So now we need to understand which is more important in these cases. Like if I say a non-cancer patient as a cancer, then what consequence it may bring. So then we can ask a second test to verify whether that cancer is actually a cancer or not. So in this case, we can prefer this high recall and lower precision value. But in case of spam and non-spam classification, it is important, like I might miss some spam email, I might mistake some spam email as non-spam. It is quite okay in this case. So in this case, we will prefer high precision value over recall. And there is one more trade-off parameter matrix we can use, which is called F1-Score, which is the harmonic mean of precision and recall. So what we want to do, we want to balance these two forms. We want to keep these two trade-off in a balanced form. If we want that, like we want less false positive as well as we want less false negative in an imbalanced data set, then our best matrix is F1-Score. So what it does, it balances the precision and recall, particularly useful when the classes are imbalanced, as I mentioned, and it is higher value is better. So if it gets close to 1, that means it is better. Now the question might come, like which matrix should we use in different case scenarios? So first of all, the accuracy. We can obviously use accuracy when the classes are balanced or nearly balanced, we can say. Precision when false positive are costly, like the spam filtering, as I mentioned. Don't want to miss any important emails in this case. I want to see all my important emails. So if some emails are falsely classified as non-spam, some spam email falsely classified as non-spam, I'm okay with that. So in those cases, we always prefer the precision. But in disease detection, like the cancer and non-cancer, the recall is more preferable choice, because I don't want to miss any disease cases. If I say some non-cancer sample to non-cancer, that means it may harm the patient. And last of all, F1-Score, when we need a balance between precision and recall. So some real world example. So in cancer screening, as I mentioned, high recall is critical. Don't want to miss actual cancer cases. Some false positive are acceptable, and in that case we can do one more or further testing to make it sure. In fraud detection, like the spam mail or some other type of fraud detection, balance needed, like catch fraud without inconveniencing our customer. So in that case, maybe F1-Score is a better option. So let's summarize what we talked today. First of all, we start with confusion matrix, which shows the prediction versus actual result, which give us an overview what model is predicting in terms of true and false. Then accuracy is overall correctness. If the data set is balanced, it is a very good matrix. Precision, the correctness of positive detection. Recall is the ability to find all positive cases. And F1 score is the balance between precision and recall. So this is all about. Thank you for listening. We will come back in another video.